Okay, so what Kovanova does in the blog post I read is something actually pretty neat. She says odious numbers we're going to call ones and evil numbers we're going to call zeros.
Okay.
Okay, so you can think of the analogy with even and odd here.
Mm-hmm.
Okay, and for any sequence of ones and zeros, 1, 0, 1, 1, 0, 1, we can create a sequence, an increasing sequence of integers based on a 1 is an odious number and a 0 is an evil number, and all we're going to do is to create this sequence, we're just going to insist that our sequence is increasing. So this 1 tells us to look at the smallest odious number that's not in the list yet, which is what?
1.
1. This 0 tells us to look at the smallest evil number that's bigger, is what I want to say, that's bigger than any number in the list so far. So what's that?
3.
3. What does this number tell us, do you know?
So we have to look at the
Next, it'll be the next smallest.
next biggest odious number.
Okay, which is
4.
4, because 4 is bigger than 3. So we're going to skip 2. 2 is not going to be in this list.
Yeah.
Okay, what comes next?
Then the next smallest odious number that's bigger than anything on the
7.
list. So, but next smallest odious number.
Okay,
7.
7.
And the next biggest,
Evil number,
which is
9. Then 11 for odious.
Okay. And then however our sequence continued, we could just look at the two lists. So this sequence here, 1, 0, 1, 1, 0, 1, turns into this sequence of integers, 1, 3, 4, 7, 9, through this process that Kovanova talked about. And that's actually pretty interesting. So she says, why don't we go one step more than this? We're going to make a list of numbers,
Yep.
however we want. Why don't we start with just plain vanilla sequence of integers, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then we're going to turn this into a sequence of ones and zeros based on whether they're evil or odious. So what would the sequence of ones and zeros be here? Is 1 an odious or evil number?
Those odious.
Okay, so that would be a 1.
Then
Odious.
1, 0, 1, 0, 0,
0, 1,
1, 1.
Okay. And now we're going to go back through the process Kovanova just described. Now, do you think we go back to the same sequence?
We could, because I think it looks like we'd go back to the same sequence.
Okay, let's see.
So
So
we start with
1, then 2, and 3, 4, 5,
6.
6, 7, 8.
Okay.
Yeah,
All right, so it seems like we go back. Do you think you always go back to the same sequence?
I don't know.
I don't know either.
So
So you give me a sequence of numbers here.
a consecutive sequence.
Whatever you want. Any set of numbers any set of positive integers that you want.
Let's see.
Give me like
10, 13,
try to keep them below 17.
9, 8, 2, 5, 14.
Okay. Do you think when we go through our process we're going to get back to this?
No, definitely not. I don't think.
Okay. Why?
Because this is gonna turn into the smallest evil number.
Okay.
So then that's 3. 10 would turn into 3.
Ah. Okay. So
I think it has to be consecutive numbers.
okay. Yeah, the other problem this had is our sequence is going to be increasing just because we force it to be increasing,
Yeah.
and this sequence
Isn't.
isn't. Okay, but all right, so you have another idea. Consecutive, go ahead.
So maybe 9, 10, 11, 12, 13, 14, 15, and 16.
Okay, interesting. Now, is this going to turn into a sequence that starts with 9?
Well,
Well,
9 is an evil number.
no. But
What's it going to start with?
it's going to start with 3.
Do you think it'll be increasing?
Um,
Sorry, do you think it'll be consecutive? Even though it doesn't start with 9, do you think it'll be 3, 4, 5, 6, 7?
I don't think so.
Okay, why not?
Because the next one's 10,
Uh-huh.
and 10's an evil number.
Okay.
So it would start with, it would be go 3, 5.
Oh.
So it looks like maybe you have to start with an odious number.
Interesting. So what we're seeing is for at least one sequence we saw, it actually did go forwards and backwards. For another sequence we saw, it didn't. And then for the last one we saw that it didn't. So what I did is I wrote a little program on Mathematica that's going to do this for us. And so we'll play with sequences, and we'll see what various different sequences of numbers turn into.
Okay.
All right? All right, let's go upstairs.